Okay, today we're going to look at the algebraic expression. So in our textbooks, let's go to page 74. If you have a textbook, let's go to page 74. So on page 74, that's where we're going to discuss the algebraic expression. At the end of this lesson, all of us, we must be able to understand the differences between algebraic expression and algebraic equation, because these things are not the same. So therefore, let's write it as a classwork in our classwork books there. Classwork, the date is 21/02/2022, and the topic is algebraic expression. So I'm going to start with the algebraic expression. So once we understand algebraic expression, then we go to the algebraic equation. So therefore, on the algebraic expression, we start by saying that number one, we work, on this one we work with variables, variable, coefficient, and constant. Constant. So this is like this. So for example, let's say we have 4x to the power 2 plus 3. Let's say that is the expression. So on that expression, 4, this 4, we refer to it as coefficient. 4 we refer to it as coefficient. And the x we refer to it as a variable. X, we know that is a variable. And 3, that is here. You can see that it's just a number on its own. So if it's a number on its own, we refer to it as a constant. A constant. So that means on this expression, we're looking at the variable, the coefficient, and the constant. This is what makes the algebraic expression when you have a variable, coefficient, and a constant. And the other thing, on algebraic expression, the letters, can you see the letters? The letters always represent the variable. The reason why we say that this variable is all because it represents an unknown number which can vary at all times. So that means that the variable can always change. So therefore, that's what we refer to it as the variable. Let's write it down to say letters are used to represent numbers whose value is unknown, and that value can change. So that's what we refer to it as the variable. These are the letters, and in this case our letters is x, and if our letters is x, we refer to that letter as a variable which represents an unknown number. And the other things that letters, a variable in an expression is often raised to a power. So the one that is raised to a power, we refer to it as the variable. So in this case, x squared is variable, and it's raised to a power of what? What is it that the variable is raised to a power? What is the number that is the power there? 2 is the power, eh?
Yes.
So 2 is the power is raised to the variable. And the other things that we said, what is 3?
Constant.
And it's constant. And a constant does not change. Constant remain like that forever. So 3, this number that is standing alone, we refer to it as a constant. And we know that in an English constant context, whenever we're talking about the constant, we're talking about those things that they don't change. They remain the same. Eh? So that's why if that number is not the same as the letter, because the letter can represent an unknown number, and that unknown number can change any time. And the 3 will always be good. Even if you go to somewhere else, maybe for other places, 3 will always be 3. 3 won't change. That's why we refer to these numbers that are unknown as a constant, because they don't change. And the other thing is that a coefficient is always found just before the variable. Eh? So all these numbers that we see just before the letter, we refer to them as the coefficients. And the other thing is that a coefficient, let's just indicate to say a coefficient is the constant. Eh? Because we know that numbers, they don't change. Okay? So coefficient is the constant by which a variable is multiplied. In an algebraic expression. So, which is this number? Which is 4. 4 does not differ much from 3. But they differ in such a way that the 4 multiplies the variables. Eh? Immediately when the number multiplies a variable, so that number is not a constant, but we refer to that number as a coefficient. And here in this case 4 multiply x. So we know that in maths, when there's no operation of positive or negative, so therefore these they multiply, even if it's not indicated that is a multiple. So therefore the other things that we must also understand, what is the like terms? Like terms in algebra. How to identify the like terms? How do we identify the like terms? For example, let me give you this context to say you have 2x plus, let's say 2x squared plus 3x plus x. Which ones here are like terms? X and 3x. And how do you see that they are like terms? How do you identify that these ones, they are like terms? The variables have raised to the same powers. Yes. Can you see x is if there's no letter, you know that it's 1 again. Yes. And even here there's no number, you know that it's 1 and 1 again. Yes. So if they are raised to the same power, we can get them as the like terms. So therefore, when you simplify them, we're going to say 3x plus x. So therefore, then it's going to be 4x. So if they are raised to the same power, they are like terms. Yes. So this one, we only see them by the raising to the same power. So anyone with a question regarding this? So therefore, even if we do have kind of expression, let's look at the kind of an expression, because we know now that there is no equal sign, and it's made of variable, coefficient, and constant. And we also have kind of expression. So before we look at the kind of expression, I want to indicate to say, number one, let's take this one into note to say a term. This is what we call a term. And a term is a combination of number and variable, involving multiplication or division. So term means that it involves two things. What are those two things that are involved in term? Is a number and a letter or a variable. So therefore, it combines a number and a variable, and can be involved in either multiplication or division. So therefore, if it's 5x or 5 divided by x or x divided by 5, can you see that it involves what? It involves division, and it also involves the multiplication. It's 5x, 5 divided by x, or x divided by 5. So therefore, we regard these ones as terms because it's a combination of a variable and a number, and they are involved in the multiplication or division. So these ones we refer to them as terms. So therefore, moving forward with this, you can also look at the kind of expression. So the kind of an expression, kind of expression we have monomial, and monomial consists of only one term. Consists of only one term. For example, let's look at the example. The example can look at 5x. 5x is a term. How do you see that is a term? It's a combination of a number and a variable and involved in multiplication. So therefore, 5x or 7y, all these are the monomial because it consists of only one term. And we also have binomial. Binomial consists of only two terms. For example, x plus 6. X plus 6 are two terms. How do you see that there are two terms? How is it? Because of the addition sign. If there's an addition or subtraction sign between the terms, so this you can say is 1 or 2. Therefore, we refer to them as the binomial, and also have trinomial. Consist of only 3 terms. So therefore, for example, so we have x squared plus 4x subtract 3. So we can see 1, 2, 3. So when they are separated by addition or subtraction, we refer to them as a separation of terms. Remember, these are the operation sign. And also have the polynomial. And polynomial, we say that expression with any number of terms. Any number. That is the main. So therefore we refer to them as the polynomials. And we have, for example, so which is y to the power 3, subtract 4x, add 5y plus x squared. You can see that the letters are not, it's not only one letter. There is a y letter, there is also an x letter. That indicates main terms. And when it is main terms, we refer to them as polynomials. Are we understanding? Are we clear on this one?
Yes.
Okay, is there any other question regarding the expression?
No.
Okay, if there's no absolute question there, I want us to get the equation now. So this what we did, everything that we just did here, it was about the expression. And now, let's go to the equation. And the equation, I'm going to waste time much on the equation because they are almost the same. The equation and expression are almost the same. So therefore, let's say now is an algebraic equation. So now let me start by writing like this to say it's x squared plus 4x subtract 3. And the other one, let's say this is A, and this is B. I'm going to write the same thing to say 4x subtract 2 equals to 0. So what is the difference between number A and number B? What is the difference?
The equal sign.
The equal sign,
Yes.
B has equal sign,
Sign.
while A does not have an equal sign. And in most cases, an expression, when the question comes to the expression, the question will say simplify. But on equation, the question will say solve. So that means you must solve for the value of unknown on the expression, on the equation. But on an expression, you only simplify because you are not looking for the value of unknown. Here, our value of unknown is x squared or x. That is unknown. So therefore, we start by saying that on an algebraic equation, let's say algebraic equation. So which is algebraic equation? This is a statement of the equality of two expressions formulated by applying to a set of variables. The algebraic operation. We have the algebraic operations there, which is addition, subtraction, multiple subtraction, which is like this, ne? Multiplication, ne? Which is like this, and division. Division is like this, or sometimes raising to a power, ne? So when they raise to a power is another set of operation. And equation can be used to represent and help to solve problems. So most of the time, equations are used to solve the problems and to represent. Because sometimes we are given the weight equation, and that weight equation, you must convert it into the numeric equations. So therefore, and remember, they are used to solve problems. Let me indicate to say equations can be used to solve problems. Equations can be used to solve, to represent, and help solve problems. And what does the equal sign mean on an equation? Like, for example, the equation that we just wrote there, what does the equal sign mean? Is the first time you hear the word equal sign? No. Okay. Equal sign. What does equal sign mean there? You hear most of the time they talk about the equality. Eh? What does the equality mean?
The equal sign shows that what's on the left side is equal to the right side.
The both sides are equal again. Yes. So that means if you have 5x plus 2 equals to 0, we need to ensure that the equation is true when we solve at all times to say both sides are equal, and we must ensure that the equation is true. And you can only do that by following the order of operation. The order of operation, we know that is both mass. Both mass. Both mass. And we follow this both mass in order to solve the equation. And the other thing to say, to solve an equation, you must apply the same principle of expression. You apply the same principle of the expression, and the most important part, keep the two sides. Keep the two sides of the equation equally balanced. Keep the two sides equally balanced by solving. So for example, I'm just going to give you an example with this one. Let's just quickly solve this one. The question says, as an example, solve for x. And remember, must keep the equation equally balanced. If you're supposed to keep the equation equally balanced, for example, number A, you must have 3x subtract 8 equals to 34. That means two sides are equal. How do we ensure that the two sides are equal? We must find the value of x. That makes the equation to be true. So how are we going to find that?
We move 8 to the sides of the equal side.
We can move 8 to the other side. Or we can look for the additive inverse of 8. If it's negative 8, that means it's going to be positive 8. We add the additive inverse of 8
both sides.
in both sides, ne?
Yes.
Which is the same as moving. Yeah? So negative 8, 8,
0.
0. Ne? So therefore left with 3x equals to 34 and 8
42.
is 42. Ne? And now, since we are looking for x, we must multiply by the 1 over 3 is, we must multiply both sides by 1 over 3, ne? Which is the multiplicative inverse of 3. Multiplicative inverse of 3. So we're going to multiply by 1 over 3, multiply by 1 over 3. So 3 divided by 3 is 1, ne?
Yes.
We're left with x. 42 divided by 3, yes. Okay?
14.
It's 14. Okay, now let's test whether the 14 is the value of x. Right? And how are we going to see that is the value of x? When both sides are equal. Again.
Yes.
So let's, when we see x, we're going to put 14. Subtract 8 is equals to
34.
so therefore both sides are equal. Because remember that 3 multiply 14 we get 42. Ne? 42 subtract 8 we get 34. So which indicate to say both sides are equal. So then let me give you a homework as a conclusion to this lesson. Ne? Our homework is going to be like this. Homework. 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 The date the guy didn't one. Yes. Number 1 says solve for x. Ne? Number A, x subtract 4 equals to 12. Number B is 3x subtract 7 equals to x add 3. And remember, we use the order of operation, which is the important thing in order to solve the equation. We came to the end of the lesson. Eh? Anyone with a question before we wrap up? No question, eh? You understand?
Yes.
Okay, thank you very much. We'll meet again. Okay.